Hello, everyone. My name is Krzysztof, and welcome to my presentation. I know this like be lazy session just after lunch, so I hope I will not bore you to death. Before I go to the topic of this presentation, which is context body and new tool I want to talk about, I want to say a few words about me and other stuff. So I'm Scala programmer for like 7 years now. I think for over 5 I'm doing Scala tooling for a big Scala projects. I bet I can double the size of your project and triple, and probably like my project I'm working on as a, like providing tooling for those is probably right now is like few million lines of code, like 8 or 9, and few hundred developers all doing or programming and developing on the same single branch. So there's plenty of problems, and so it means there is like plenty of things I need to fix, and so to make it them work. Basically, we are saying if something works in our code base, it means it works everywhere. I'm from Virtus Lab. Virtus Lab, we are the company that, except for like doing Scala, big data, a bit of Kotlin, front end stuff, we're trying to support community as much as possible. We run a lot of the user groups in Krakow. You can see some of the logos here, as well as a big conference that I want to invite you in October in Krakow. It's not only related to Scala. There is multiple spheres with different topics all in the same time. So it's like plenty of opportunity to actually share experience. So there is Scala, there is some React stuff. I'm one of the organizers, so I'm probably biased, but I think it's like the biggest event in Krakow, at least for me. Yeah, and the last thing that is not related to the presentation I want to talk about is developer jungle. So this is our stand, and there is many small lightning talks about different topics. You can see here John talking about one of his libraries. Come here to our stand. There is on this website, there is a full schedule, so you can pick whatever you like. We're pretty much running all the time in the breaks and during the talks. So if you don't find anything interesting, maybe we can offer you something nice. So that's all of the things that are not related to the presentation. So slides are here. I probably need to do a push. I don't know if I pushed the last version, but there is not much in the slides because I will do some demos as well. So now let's come to the presentation. So I want to talk about the context body. You probably have no idea what is that because it's the first time I'm like speaking publicly about it. This is a tool that I am and Virtus Lab are developing, and our aim is that this tool will know your code better than you do. For now, it's a long way to get there, but for now there is like few aspects of the developing the software that we want to cover in the context body that we usually do ourselves as the developers. So basically, the knowledge that we gather during our development, daily development, like fighting with the code, providing new features, we build like this kind of big pile of knowledge in our heads. And okay, this is nice, but we want to make it more robust, make it more so machine can help us as well here, computers. It means that this knowledge stays with the project. Not like if I'm changing the project, it means all the knowledge of my previous project is pretty much useless. It's only the experience I can learn from. But I will not put like, there was this strange test that fails like once in a while, and yeah, everybody knows about that and ignores that. This is like a piece of knowledge that there is in the project. And when I change the project, it's gone. And new developer join in, and yeah, the test fails, and he goes, "What I broke? What? This is my fault." And she's trying to like debugging, nothing. And then there's like someone, "Oh, this test fails. Don't worry, ignore it. Like we know it's like on Fridays it always fails. Like run it tomorrow, it will be fine." So this is the context body is maybe not aimed for this kind of long people that live long, like stay long in the project, because they usually build this kind of map in their heads. This is more for the new joiners, especially the one like I'm joining a new project. This is like maybe first time I'm doing Scala, and I feel Scala is complicated, and I feel that everyone in the project is like way smarter than I am, and I don't know how I pass the recruitment process, so I'm scared to ask. Another thing, like there is projects. Scala is quite old. Like this is the 10th Scala Days. And Scala exists before that, so there's like code bases that has 5, 6, 10 years. So there is plenty of legacy of Scala code. Nobody probably realized that there is plenty of legacy Scala code. And sometimes you have to dig in those code. This is not the code that is wrong. It's a fossil, so it was developed like long time ago. And there was reasons why it was developed, why it was good. But right now, you see, it's like, what? is that? How does it work? Why it's there? Or another place where we lack knowledge and we need some tools is like there is a code formatting was added to the projects. Like for example, Scala FMT was introduced like 2 years ago, something like that. And I bet that if Olafur gets credit for each of the line that the Scala FMT changed, he will like mostly, you know, the top contributor to most of the projects, including like really executive ones. And this is the case that this is a big problem for us. We need to format the code and like 10% of lines actually showing the actual line that was changed. And yeah, going past that, I don't know if you have tried, it's not good. I will show you how we can do it quickly, but without any help. And there's plenty more reasons why you want to dig into the history. So, and try to find out about something strange, like this thing. They found many like this in the like single area, I think in Nebraska, starting from 19th centuries. And this is I've got this kind of feeling when many times when I am looking in like old code, like, okay, it looks, there is a like symmetry, there is something there, but I have no idea why. I have no idea what is that. And it was the same puzzle for the paleontologists for a while. They've got different ideas, and there is no context body for paleontology, so they have to like, you know, research and try to find out what is that, why is there, how does it look like, because there is no way that this thing is actually like something not made by a living creature, because it's like we don't see any process of anything except for living creatures to make something like this. And we got the same problems with our code. So let me show you something that all of you, I think, who's not using SBT? What are you using? Gradle. Gradle also supports Zinc. So this is the part of Zinc. So this is the incremental compiler for Scala. This is the thing that actually makes your Scala compilation relatively short for the small changes. Probably the piece of software that we like. If Zinc is not there, like if we don't have incremental compiler, nobody will use Scala. That's my bet. That is my guess. And this is like the heart of that Zinc. This is the method that actually doing the cycles. Zinc is working in cycles, so try to recompile like small piece of Scala, try if something else needs to be recompiled, and doing it until we recompile everything or there is no more things to recompile. And you might see this is quite old. If you go into the git blame, at some point project was moved, so it's not really valid, but there is a plenty of code in Zinc that was written by Mark Hara, like long time ago. It's probably, pieces of that code is as long as SBT, so I've bet like 10 years. And due to my work in my project, we use Zinc heavily to actually cache the compilations and try to reduce compilation time using like Zig artifacts. And I dig heavily in the Zinc code, and this fossil moments, I've got many of those here. So one of this thing is like, there is, I don't know if you can see it clearly, there's like is class file manager. And you might think, okay, I'm doing a compilation here, so why compiler is doing the managing the class files? So why it was introduced here? And I want to find like a commit that introduced that. So yeah, I can do git blame. I don't like using git blame from command line because the output is really wide. There is like, usually if there is like some moves, there is like a path to the file where it is, so I need like 3 screens to see anything in the output, in the command line output. But I can use IntelliJ. There is this nice annotate command, and yeah, I can see that this line was changed by ego. And I look at the commit, is like prefix all types with X if it comes from a given package. So it gives me I don't know why it's here. It's like I know it was prefixed. So I have to dig in as the scientist trying to find out what was this strange thing is. So I can do it using Git, like I can come back to the history, like check out to the point on that commit, going to the parent and do other stuff like that. But IntelliJ really conveniently adds this annotate previous revision command. So it's basically doing all the nasty stuff for us and open a new Windows, and I can see like the code as it was before the commit. And yeah, you can guess what is that commit. Reformat everything with Scala FMT. And yeah, we can go back again, and And we actually, in order to get to the point when we actually know who introduced the Scala class file manager, we actually go to the end of the history because it's pretty much the first commit in that file that introduced it. So not much help. But yeah, in most cases we'll find what is there. And we will need to do like many steps back because this piece was changes quite a few times during the file history. In order to prove my word, you can see here how old this is by looking at the one of the dates, maybe that one. It's like 2016, so it's quite new, but there is like older one. Yeah, and we can do it manually, like, try to dig and try to find the remains and try to sort the puzzles. So this was the same thing with that. So scientists trying to solve this puzzle, there was many theories. Like there is like some kind of plant that grows around other plants. There is sea sponge, but at some point that examining closely, they found like small bones and more of that small bones, and it appears that they come from the same animal. And the problem was solved when they actually find the bone within that thing. So this is not a plant, this is not a bone, not everything, but this is rather a burrow that was fossilized. So there is this nice creature there that is called Paleocastor that lived. It's like a beaver that lives on desert. There was strange things in the past, and he actually dig this kind of deep burrows because he needs to dig deep in order to get like a nice temperature to live in, because the night was really cold and the day was really hot. And if you dig deep, the temperature is pretty much the same. And apparently, the easiest reason, this is way to actually dig deep, is actually doing the spiral down there. And because if you just go straight, you will be trapped at the bottom. And I learned like many Minecraft players got problems with that. So they dig deep and there is like no way to get out. And this was filled with like harder sand, and this fossilized. So yeah, it was there. And how we can do better with our history? Let me show you. And I have to come back to the original file, and then I have to turn something that is called Smart History. You are not going to find this in your IDE. This is something that Context Buddy provides. And no fireworks, but we can see that we got this kind of strange dots. And please tell me if you can see that the different names got different colors in the background. Kind of the way how the presentation mode in IntelliJ works means that the underscores that should be like most visible get small, they get the same size as with normal text, so it's maybe harder to read than in normal mode. But now we can see there is like plenty of colors here. So, for example, this is annotated with that is X class file manager, and it was annotated by X ego as we start. And then near to it, there is other thing that was introduced by Grzegorz Kosakowski long time ago. As you can see, it's like in the 70s. Actually, probably someone just messed up my Git is not smart enough to find out the correct date. But yeah, it points out to the actual commit where this thing was introduced. And and you can see it's not only, there is no sign of the Jorge change to reformat everything. I can do git blame again. Nothing there. It's just where the actual change took place within the actual token, within the actual thing. And you might guess, how does it work? What is the kind of magic? There is no information in Git in order to do so. Yes, and you are right. And this is where Context Buddy is, and where Context Buddy works. So let me show you. I have to change repository because Zing is quite big, and actually showing you everything there, it would be like really hard. How does it work, more or less? Yes, I also click 2 more times. So we got like a pretty simple class. It makes no sense there. Do not find any sense here. Just to put like everything that comes to my mind. And as you can, maybe I will. One more thing. Oh, maybe not. As you can see here, this is like a normal class, nothing else. And there is a history here, so we got multiple dots here, different colors. So how do I know that information? This is all because I'm using tokens. So let me show you how Context Buddy sees that file. It's something like that. So it's basically the list of everything important that I can get from code. I probably should add some int literals here as well. But you can pretend that they are here as well. And now, if I keep the file in that mode, I'm pretty easy to keep track of the history, what was going on. Because if I, for example, introduce a parameter here, like this one, then it means that around my method and type is not changed, and it will be in the same order. So using like simple diff, I can compare those and keep track of the history. So you basically met a context body. That was the first thing that context body does, and I hope, and for now, it's the thing that it does best. But actually looking at this simple code is really useful. I mean, but it's not, I'm not satisfied with it. I want to get more, because I think there is more. So this thing again, this is not a fossil. Like fossil is a part of living thing that was fossilized. But those burrow, those spiral, is not a fossil. It's just a trace fossil. So it's something that living creature like made some sign of it out in the outside world, and it passed the information to us. And there are more other examples, like the footprints of dinosaurs. They're quite common. There's like footprints of other maybe less sexy creatures like small ammonites or other ones. But there are also like more exotic ones, like they also found like a poo of the dinosaurs. And to be honest, this is more, in many cases, provides more information than the actual bone. Because if we got like 200 bones, okay, we know the bones, we can measure stuff, like the amount of information people can get from bones is like crazy. But when you got that thing, it proves like, okay, this is a trace of that plant, so this plant was high, so it was high as well, or it was jumping or flying, whatever. And if you think about the code, it's the same thing with the code. All the tokens, all the things, all the code itself, you can think like as a bone. So it's the thing that makes our code. But there is plenty of information there as well that is different. So types. In most cases in Scala, we don't have to add the types in many places. We only need to add types where we really need them. But not only types. If you are using a library, who's got a problem with like using the wrong library or having problem with dependency resolution in last 3 months? Raise your hand. Yeah, so you probably know what I want to say is like sometimes you want to do something, it's failed to compile because like the library was evicted and it's changed. So this also like a trace information. It's not within the code, but it's rather the environment. And you can think about more stuff like output from tests, logs, their test results, performance characteristics, more places, more things like that can like the code affects the world outside, or the things that affects the code. So can we ask context body to provide this information? Let me show you. So let's start with something I've called the map hell. So imagine this is like a not simple thing that fits on the slide, but this is actual application. So we got this thing. It works fine for like half a year. There was some minor changes. CI is green. Everything is fine. There is not much traffic on our application right now. Let's say we got a student application for students. It's a summer, nothing going on. And then it's like September or October. The application is like, and the server is like red hot. And it wasn't last year. There was not big features introduced new, like everything works fine. What's going on? So smart people actually debug it a bit, do some kind of the stack traces or stuff like that. And it turns out that we do some caching here in that line. And it turns out that it does not work. Like the cache that we create does not work. So what's going on here? So the first thing, let's say you are just joined the project. You were given this task, like the version was reverted, so the production is not on fire, but you have to investigate what's going on here. So you want to see, okay, what was changed? So it was introduced like a month ago, probably there is a change somewhere here. So let's use a git blame, and its initial commit in the project. So the DINE wasn't changed. There was like a few small changes, like in different cache on the top, and there was like probably line deleted or something in the top of the file. And imagine that there is a 300 lines of code here. So you probably won't be able to see those 2 lines changed if you look at that file. Any idea what went wrong here? Yes, and context body is on. So you can see there is this brown dots here. But since the code wasn't touched, there was no change there in the tokens itself, in the code. It cannot help you with this mode. So we can actually be smarter. And come on. Where are you? Yes. And that's context body for help. So we got a small menu here. I'm not really good in designing user interfaces, so probably it can be done way, way better. And by default, there is a tokens that are selected. You can see also the comments that affect this line. Yeah, this is really small repo to show, so there is not history is not long. And now we can few things to pick from. Let's go with symbols. Did you notice the change? There is 2 dots in the new cache. So there was a change. So the actual symbols or the types or whatever you want to call it, something affected that line in the history, even though the code was not changed. Okay, you were looking at that. You can go and try to dive and try to understand what's going on here, but context body will help you here. So you know that this was introduced by Edward, and it was many, many problems. So let's see what problems was there. You noticed it's become red, and now when I hover over that, it showed me what was the previous token there. The change is really small. Basically, it used to be mutable, but it becomes immutable. You might ask, yeah, this was a good move, like it should work. No. When you do a caching, and this way, you really want mutable maps. This is anti-pattern, you should probably not do that, but come on, this is a legacy code. It was there from the beginning. Someone was probably learning Scala and developed that thing. So yeah, why was the problem? So let me show you the diff from that commit for this file. So basically there was a immutable map imported top level, and probably someone, when this cache was introduced, like picked this on the review and said, okay, you should remove this import on the top of the file and add it in the place where it should be. And this is a completely valid thing. But here there is this map that was mutable and right now is not, and this causes problems. And since mutable map and immutable map works the same way, except for the effect that with mutable map the result is cached, the production works fine for a long time, the test was green, everything was fine. So that's the first place where context body can help us. Like actually we can see what was the change within the symbols, within the types that was there. There's other situation I want to show you as well. So another case. This time no mutability, no side effects, except for plain line, but it doesn't matter. We've got there's an application, and we try to get we pass the arguments and convert them into to parse them to the ints, and they are in array, so we don't want an array, so we introduce collection breakout, and then the string line represent the rest of the application. And also there was a change somewhere, and the results are different. So what was the change here in that file? Let me show you. Maybe this time we start with history. Again, basically some of the traits was changed somewhere else. It's all in the same file, but in your application probably will be a completely different place. And token, again, here in the problematic place where the output was changed, are not affected. There was no change here. So we can use symbols here as well, but we've got other thing called definition types. And this is way less instances. And as you can see, there's 2 changes from point of the definition types in the middle. So basically where we got the train defined. And yeah, this makes sense because we changed a new base, but we also changed something here. Let me show you what was changed. Again, we're using this. It's also a tiny change, really hard to spot when you do a code review. Basically, the set was replaced with sec. And it means when we got on the input 115, previously it was just 15 coming out of that because set remove duplicates. When you change it to seek, we got all the output. And it's only because we changed the definition type in one of the traits. We probably should put a concrete definition of the type here and it will solve the problem. But again, this is a legacy code. This is a code written long time ago, and probably someone was super proud when he wrote that code that he don't need to provide types here because this is what Scala is for, yeah? The types are. Compiler can guess type for us. Okay, another thing that we can inspect. So this time, there is no change in that file. It's all the same initial commit. And there is no run there, but the output is changed a bit, formatting of the date was changed. What was going on? The file was not changed, there was no any change. What was that? Let's use the origins. And again, you can see there is something changed here. So again, let's try what is the affecting thing. And you might see that it actually grabs the origin of the file. So if there is anything in the code, it comes from somewhere. Either it's a source file or jar, and we can just, see that, and okay, someone just downgraded the Yoda time library. How might it happen? The way how we resolve dependencies in our project might be surprising many times because the dependencies might be removed, which might affect other libraries. Because of the eviction, transitive dependencies, generally dependencies are a mess. And this is a simple case, but I've debugged many problems. For example, the worst one are Guava, because Guava are not binary compatible, and sometimes they are included within some other libraries. And I debugged many times the problem that application was failing with abstract method errors on the production, even though the code compiles because the class path was changed a bit. Yeah, this kind of problems. So, and the last one I want to show you here is my favorite, because Scala actually, the compiler itself introduced a lot of stuff within the code. Like, for example, implicit. So this is the same example as before. And when we annotate synthesis, so basically the stuff that was injected by the compiler, we can also see that the implicit here is changed. And this is the test. I wanted to find out if context body actually can solve actual puzzlers from Scala. And auto-tapling, I don't know if you've heard about that, is one of the problems. So basically you change something in the code, and there is something that can accept an object or anything that tuples can match. And before it accepts like different amount of parameters, so Scala see, oh, I can tuple it, so I can make it turn into the tuple. So here, when I again turn on the synthesis, it will show me that there is an apply method that was changed. So basically, the tuple was introduced. So yeah, that's the few things that context body can help you with this kind of trace information from the code that are not there but affects your code. So you might want to ask how you can try that. The problem is that there is no open, its context body is not open yet. It's not because I don't want to open it, but I don't want to open it too early. Because since the things I show you with how we can read the data are simple or relatively simple. Or simple, plus you have to deal with the IDE, or like actual code, UI code to display it, which I'm not really good at. But I will try to find some help, don't worry. But the actual problem is actually to produce that history data. And this is really tied to the way how you develop your software. So how your CI pipelines work, how do you play with your branching strategy. And I really want to try it out on few like different projects before I will go to public. But if you really want to try it, contact me. Either you can write to contextbuddy@virtuslab.com, like ping me on Twitter, find me on GitHub, grab me on somewhere on the conference, or like contact me anywhere else. I will be more than happy to talk. I will ask you some question about how you can get it running in your application, and yeah, and we will like decide like how we will introduce it, and I will ask for feedback because the feedback is the thing that drives this kind of programs. And when it's ready, I think we will at least, because I'm not sure how much of that part will be like go completely open to public and for free, but at least some part of that will be public. And I can end my talks here, but I really want to talk about the future. So what I'm currently working on in Context Body and what will be there, because I know I want to get there. What I showed you right now is not much of actually gathering the history. I'm gathering the context and like knowing the code better than you do. It's like smart history. And this is like probably the things that start everything. It's like I was thinking how I can make the browsing of the history better. And this probably should like ends up like right now, so in 20 minutes of the talk, not much for a Scala Days. But then I was thinking how I can achieve that and try to implement some stuff and realize I can do more. I can gather more knowledge because the things I needed for the history are really good, or I hope they will be really good, to actually learn more about the code. You might ask why I picked this thing as a background. This is a Machu Picchu in Peru, old abandoned Inca cities. Why I put this as the background for future? It should be like a past. When I was there, I was told really heartwarming story how the schools in Inca times works. So basically, if you were building this kind of houses, they were like really amazing because they were able to withstand the earthquakes. So there was multiple earthquakes around the Machu Picchu, and most of the buildings, everything there is still intact. When the Spaniards came there, like pretty much every church was rebuilt every 100 years because of the earthquake. And those buildings can last like And the funny thing was, like, if there is a building built in, like, on top of the some kind of old Inca building, it was fine, because of the skill how the people get actually putting the stones with pretty much primitive tools. But coming back to the history I was told, if you are building this kind of thing for, like, let's say 20 years, and you are really good at it, you just stop, even though you can build more, and you start, like, teaching others. So there was a school, so, like, the young people or childs go there and they learn how to build stuff. And I was thinking, yeah, this is really nice. And I realized we are doing the same with the projects. There is, like, old senior developer that actually is there forever. And there is a new guy coming in, and he sits with him and showing everything about the project, about the technologies, designs, and whatever. This is really nice, but there is a problem. Like, the Spaniard came, and, like, in 20 years or more, there was no Inca Empire. There was many reasons because, like, why it happened so fast. But one of those was, like, Incas does not have a writing, so they don't have any kind of mechanism to preserve knowledge. And I want to claim that this is the same thing for us, for software developers. We've got, okay, you might say we got writing, we got documentation, like, we got a tweak with everything. Yeah, we got that, but to be honest, do you see a project with good, like, developer information, like, that is really up to date? And I do not. So if you got one, like, lucky for you. But in most projects, there is documentation for users. There is documentation how to start your, like, to set up environment. There is the documentation how to deploy it or use it. Or if it is library, there is a good documentation about, the APIs. But the actual, if the knowledge that this test is flaky, or do not touch this piece of code because, like, it's complicated, and if you introduce anything, it may break all of that over that code. There is no documentation for that. And this is the place where I think we can introduce a context body. Because of that reason of this one single developer, we got a bus factor. Or it was put really nicely, the conference factor. So how many developers have to go to the conference so the project is not able to be developed anymore because there is no one to ask. And, or even, like, simpler things. So you're just starting. This is your first day in the project, and you got a problem, and you might ask your friend, and he'll probably know that, but you are too scared, or he's working remotely, or he's away, and you are basically stopped for the development. And right now I'm helping with, like, I'm working main project, but I'm also, like, helping to organize and, like, and work with others, like, for example, stuff for Kotlin. And there is not many developers that works in tooling, so they got, like, really silly problems in the beginning because no one told them, and they are afraid to ask me, or I'm, like, in different rooms, so there is not easy for them to ask me. So I have to come multiple times to them, asking about their problems, asking questions, and then sometimes, in, like, after 5 or 10 questions and one suggestion from me, they are able to solve the problem in 20 minutes, just because I solved this problem, like, 20 years ago somewhere else. So we've got the data, and I figured out that in the history that maybe we can use that data to actually maybe not provide, like, to answer every question the developer might have, but just, point you to the right person or point you to the right thing. So it is kind of working right now, but it's not way ready to be shipped to anyone for beta testing. But I want to show you that it's possible. So let me go to the playground where there's, like, nothing else. So I'm a new developer, and somebody told me let's build something around time. So I'm doing val now equals new date time. Okay, I'm just going to import that. I'm completely, rookie in there. And let me introduce, like, some question marks. Someone told me, like, if there is something like a constructor, if I do not know the correct arguments, it should be new, now, not new. Then I can just feed, like, these question marks. Okay, I'm really good to go. I can play with that, so I want to compile the stuff. Yay. It failed. They lied to me. What's going on here? Like, yeah, it should work. Like, there is a reason why it doesn't work, and they are not that complicated. That is what something quickly to demonstrate. And now I can use another action from context body, showing context. And here there is a context And now context buddy suggested me that there's like 2 developers I can talk to. Oh, it's me. Yeah, there's like, no, that datetime is overloaded, so you can use like the question marks here. That easy. So one of and this developers is one, like this the simplest idea, the simplest thing that I can do, because I've got git commit, authors, and so on. But I'm working on right now to provide here more stuff. Like, if you are working on a piece of datetime, and okay, there is someone that introduced the code, but for example, there is a guy that do a code review and comments a lot on, I know, he knows a lot about Akka, even though he do not write any code in Akka. So he doing a lot of code reviews and comments on, so probably he's also a good candidate to ask about Akka. With that information, you can also turn it around. So you can imagine that instead of like marking the code, I can see the change. And I can use that information. I can suggest reviewers or pick the reviewers. So someone is actually maybe better to review the code, or like some random guy that I pick. I don't know how big your projects are, but in some cases, like the cases I'm working with, it's really hard to find the owner of that piece of the code, because the ownership is buried deeply within the code history. So let me come back to my slides. But here, I'm also trying to find a way to provide help with the tests and stuff like that. So something failed. I want to know like compilation errors, and it wasn't working. Like from like positive part of the code that is good, I've got the information. It wasn't the problem. But whenever I stumble across the error, it's like no information is there. So is my model wrong? To explain why this is not wrong, but I'm looking at it wrongly, I need to tell you another story. Oh, I'm sorry, I forgot about that. Let me come back to this later on. So this is the B-25 Mitchell, if I'm not mistaken. From this, the picture taken like somewhere like 40s during the Second World War, and you can see how battled it is. It does not land; it was like destroyed on the ground. But actually, bombers that come back from the mission was really battered. But the biggest problem was the bombers that do not come back. And like this was not the biggest one, but 8 people were there, and this was like super expensive. So the US Air Force trying to find a way how to minimize the losses. So they tried to introduce the armor into that planes, but you cannot armor the whole plane because it will be like way too heavy, or the armor will be like too thin and provide no protection. So they need to try to find a ways when they can actually apply this armor for like the most effective way. So they build up, actually this is a quite amazing story, they built up a team of mathematicians to actually solve this problem, and without big data, Spark, anything like that, they have to solve it. So they create this kind of charts where the crews of the airfields and so on needs to mark like whenever the plane comes back, they need to mark where it was hit, where is like some kind of damage. And just like after the data was gathered, this was the results. So they show them to the generals. So okay, we got that. We want to work on that a little bit more. The generals saw that's like, yes, you just solved the problem. So we need to put the armor whenever the damage is, and the planes will come back more like in better shape. And they almost like send it to this kind of order to the factories. But luckily, the guy that runs these things like learn about that thing and like come to them screaming like, no, this is the completely wrong thing. Because you are looking on the data wrong. The fact that there is a damage here and the plane come back, so this is not the problem. The plane can come back with the damage with that part. If you look at the screens, like the place where the pilot sits over here, or there is the fuel tanks or the engines, there is no damage here. It means whenever the plane is hit there, it's going down. And this is a known phenomenon. This is like logical problem called the survivorship bias. And this applies to our code when you want to learn from the history. This is like the few last commits from the, I think, Scala. And as you can see, there's like green ticks on the right, which means the code that is within your history is the code that is good, the code that survives the test and everything. So you cannot learn much from that code because it's good. And if you got a mistake, you have to learn from this really nasty part of the application that you might missed. Like when the code fails to compile, this is the place where the learning actually takes place. And this is the place where Context Buddy will provide more and more information. I really want to show you that, but it's not ready yet. So basically to learn, You actually go to learn from that kind of poo that is all over the place. And I should stop here, but I want to really mention one thing. I come back to this two GIFs. Because this is like quite a new development that we got. This is the GIFs that analyze the code based on, this is based on the data from context body. We're analyzing the code as a graphs. There will be a talk tomorrow. Krzysztof that sits here will do that on our stand as a micro talk. But basically, this is the one of the place where context body almost also can help. Because as you can see, whenever you click on the ID, the graph builds. So it basically builds the graph of what you do, what you read in the map. And it can be used like two ways. Because it can be used as like you can build the query for context body. So you can go there, and you actually analyze a big piece of code. And now you can ask context body, please tell me who can help me with that piece, because this seems to be a problematic. And yeah. And the other way, context body can also fit a lot of information and make this graph even better, like providing commits. I hope it will stop at good point, but there is, maybe here will be easier to see. There is the information from context body about commits, and with precise history and some knowledge about the code, this will be even better. So I don't know if you've got any questions. If you do, it's the perfect time.
Hi, it looks interesting.
Thank you.
Just one question. Regarding you need to have the commit history, let's say, in that file. Let's say someone copied the file or changed the file location and it was not detected as a move. Would it be possible to also navigate on that history? Or
this is the first thing I plan to implement after I come back from this presentation.
Okay.
Because it was in my mind for a long time, and this is like, whenever I'm like, explaining this idea to anyone, this is the first question I always getting. So yeah,
cool.
I want to do that. Also, another case that Git is not really helping us with much is the way when you got the big file and you extract the piece of that file into the other. You really want, because there is no way that the rename can pick that because the diff is too big. But you know that is it's hard to do on based on the history from the Git like a text file, but with the information about types and everything, it should be way easier.
Okay, cool.
Yeah, really interesting talk. Good stuff. After the last story about this bomber plane,
Yes.
you mentioned that having a commit in history that, for example, doesn't compile, actually give quite a bit of information, right?
My point is like you should not have a commit that fail to compile in your Git history.
Yeah, exactly.
But you should learn from that commit. So whenever you do that, like the change locally, and you play with that, or do a feature bunch and code does not compile, this is the place where we should learn from.
Does the context body can learn from those kind of things? So
I mean, the engine is ready. Everything is ready. I just need to implement that. And this is tricky because I need to plug in into different, because there's no single place where the compilation happens or the tests are run.
Yeah. So does that mean, like in the regular GitHub kind of work situations, when you have PRs and when you're amending your PRs with different commits, and sometimes different projects do it differently, but you, at the end, before merging, you actually squash all the comments, and all of that history is lost. So does that mean that for context body to work, you shouldn't actually squash the comments? You should keep them around.
The best part of context body is it's not tied to Scala, because it's quite abstract. It's also not tied to Git. So I'm using hashes, but hashes can be anything. And I do not have like change for each commit in the history. I can work with ranges, or even I can do some mappings between the commits and everything else. So, or even more, I can provide like alternative way of how the project was changed, because I can keep that as well. So I was thinking about that, because the other thing I really want to support is not only like doing on the CI when you got tests and everything, but then you develop locally and your test fails and you fix that and you forgot about those things. There's like a strange error that comes from somewhere, and you completely forgot that, and you get the same error like a year after that, and you don't want to go into debug it, but you want to ask a tool, was it fixed before? Yes, you did it like a year ago. This is the change. Oh yeah, yes, it's good. That's the goal.
So context body may show the list of persons who have a context of some code. And what about the persons who made, for example, formatting using Scala format? Will they have context over all the files in the project or not?
I mean, depends how far you want to go back with your data together, because in order to get something more than just tokens, you have to compile the code, and this is heavy. Context body is quite quick to work, but I'm using semantic DB to get most data out of the code and some more, let's say, compiler plugin integrations. But yeah, you need to compile the code. This is the heaviest part. So you get as much data as you want to pay for those. But if you develop project from this on, when you start context body, you will get it for free because you are compiling the code all the time.
Okay.
There is.
Okay.
Okay, so I think we. Yes, thank you everyone and for coming, and if you got more questions, grab me somewhere or come to our stand. It's near the exit. And thank you so much.